Now let's learn about Cagr and how to use homemade array functions to compute Cagr. If you are working for an investment bank or investment management company, inevitably you will have to compute Cagr almost on a day-to-day basis because your clients are most interested in learning about the rate of return their investment has generated over time. Cagr is a measure that tells them that information. You can think of Cagr or compound annual growth rate as the annualized buy and hold return. What this means is that if you buy at the beginning of the period and hold it all the way to the end of the period, what is your annualized investment return after factoring in all the compounding from now and then? Hence, Cagr can be defined as one of the two ways. If you know what is your annual return from your investment each year, then you could use these individual yearly returns to compute Cagr, as you see in this first formula. If you don't know what is the individual yearly return, but the data shows you what is the ending balance of your investment each year, then you could also use these yearly ending balances to compute Cagr, as you see in the second formula. In this exercise, we also want to learn how to use a homemade array to quickly compute Cagr in one step. Before we go further on the definition of Cagr, it's important to know that Cagr is a geometric average measure. Recall that there are two different return measures in computing annual returns. The first one is arithmetic average, where you just sum up all the annual returns and then divide that by the number of years. The second one is a geometric average. Unlike arithmetic average, geometric average takes into account the compounding effect of your investment. It's important to remember that all things equal, the geometric average will be less than the arithmetic average unless all the yearly returns are equal. Let's help you make sense of this. In this simple example, I gave you 2 years of returns. Year 1's return is simply R1, year 2's return is simply R2. To compute what is the arithmetic mean, you sum up R1 plus R2 and divide by 2 because there's only 2 compounding years, 2 years. To compute what is the geometric mean, you will use R1 plus R1 multiply 1 plus R2, and since there are 2 years, you take a square root of 2 minus 1. And I can show you subsequently that arithmetic mean is always greater or equal to geometric mean. They are only equal if R1 equals to R2. Here is a proof. So on the left-hand side, you see the arithmetic mean, and on the right-hand side, you see the geometric mean. After many steps, I can reduce this equation to become R1 minus R2 squared. And since this is a square term, it's always strictly greater or equal to 0. And therefore, I have shown you that the arithmetic mean is always greater or equal to the geometric mean. Now let's look at an example of how you compute Cagr in practice. Every year, Harvard Endowment publishes their annual report that shows their Cagr of different portfolios. In this report, they published what is their 5-year annual rate and 10-year annual rate, and how their returns compare with other benchmark returns. Let's take a look at how Harvard Endowments had computed the 10-year annual rate of 16.1%. There are 2 ways to do it. I call them the long way and the short way. The long way had to first extrapolate what is the yearly balance based on the yearly returns for each year, and then use the beginning balance and ending balance to compute Cagr. The short way simply uses the yearly returns and an array function to compute Cagr in one step. Let's open our class file so we could go through these computations together. Now let's first look at how do you compute Cagr using the long way. Using the long way, you first have to compute what is the yearly balance based on the yearly return that they publish. Assuming the endowment only have $100 at the beginning of 1996. So because the yearly return in 1996 is 26%, that means by the end of the year, the investment account will have 100 times 1 plus 26%. The beginning of the second year balance is set equal to the end of the year balance from the previous year. But because the yearly return in 1997 is 25.8%, that means by the end of the year, they will have 126 times 25 times 1 plus 25.8% in their investment account, and so on and so forth. You can copy down this formula, and then you can extrapolate what is the ending balance, and together with the beginning balance, you can use this formula for Cagr to compute what is the compound annual return. You see here, this 16.1% is obtained by using the end of the period balance divided by the beginning of the period balance to the power of 1 divided by 10, because this is a period of 10 years. That's why n equals to 10, and then in the end you minus 1. Don't forget that Cagr is essentially the annualized buy and hold return. So the first step is for you to compute what is the buy and hold return of this entire period, and then you will take the 10th root in order to compute what is the annualized buy and hold return for this time period. Next, let's look at how do you use the short way to compute Cagr. The short way involves simply obtaining those yearly returns from their report together with the array formula. Then you can compute Cagr very quickly. So the formula to compute Cagr in this case is this one. So you will use 1 plus R, which is a yearly return. But in this case, since we're using array function, you will replace the individual return with the return array and multiply them all together. The function to multiply numbers in Excel is product. So multiply them all together and take the 10th root and then minus 1. So you will use the product. Inside is 1 plus the return array to the power of 1 divided by 10 and then minus 1. And then this way you quickly compute what is the Cagr. But don't forget to use Control-Shift-Enter to make the computation work.